All right, young people, I'm going to go and work through the first version of the redox test. Something new. Let's try it out. Okay, calcium is an element. An element by itself with no charge is 0 for oxidation numbers. Let's go to NH3. Hydrogen is always the charge of +1. You know that from your chart. Just also the charge of the ion. So we know that hydrogen is +1. Since there's 3 of them, 3 times 1, the total charge is +3. So what does the charge of nitrogen have to be? -3. So -3 on the top for nitrogen. It all balances out. Notice that this is +1, not +3. You find the charge of each individual atom. Okay? Over here, H3PO4, we have hydrogen and we have oxygen. Hydrogen we know is going to be +1. Oxygen is -2. And we find that on our periodic table of ions, which reminds us the charge of the ion by itself. So let's figure out what the P in the middle. Usually, with these weird ones with more than one, you find the guys on the outside first to calculate the one on the inside. So this is a total of +3, because it's +1 times 3 here. Over here, 4 times -2 is -8. What number here what number does this P have to be so that it totally equals 0? This is not a charged species, so all of these numbers have to equal to 0 right here. Okay? So this has to be +5. So phosphorus is +5. And you'll see it, 4 times 2 is -8. This is +3, +5, it's +8, and all cancels out. Over here, work's cut out for you. The charge of the ion is the oxidation number. So it's -2. Okay? Excellent. The second one asks you, is this complete or is it partial transfer? Well, it's all in this, folks. Okay, you look at the final compound and you see if this is a nonmetal and a nonmetal, and we're considering hydrogen as a nonmetal, that equals, nonmetal plus a nonmetal equals what kind of bond? Yep, a covalent bond. And that means that the electrons are still shared between the elements. If you were to draw them out, you would see that hydrogen and iodine are still sharing those electrons. Iodine is sharing them more. So this is a partial transfer of electrons. They're not completely transferred. They're still sharing them. Iodine hogs them, but that's the way it works. Copper now is a metal. Oxygen is a nonmetal. When you see that, metal plus nonmetal, that is an ionic bond. And that means that the electrons are transferred totally from copper to oxygen. So that is a complete transfer, okay, of electrons. If you were to draw out the copper, let's see, on this particular case, looks like that's kind of a weird one. Here's oxygen here. Copper is going to give it 1 electron here. Another copper, give it another one. And you end up with Cu+, and O2-. That comes together to make the ionic compound. See how the electrons are completely transferred over here? Excellent. The most important thing, though, is just know that if it's ionic, it's a complete transfer. That's it. The next one is to determine the reaction types. First one here, well, when you see oxygen, O2, you know immediately it's going to be a combustion reaction. Check the products. When you combust carbon and oxygen, you get CO2. Hydrogen and oxygen, you get H2O. So this is straight up combustion. Okay, excellent. Over here, we've got this molecule here and this molecule here coming together to make one. So this sort of thing, if you have 2 things coming together, you can call it a synthesis reaction or a combination reaction, because you're combining 2 things into one. Okay. The last one here, what's going on here? Well, let's circle and put shapes around each individual atom, and let's see what happens to them. we've got here, and we've got here. Okay. Do you see how this one, this manganese here, this Mn, is getting kicked out, and this one is coming in? So this single atom is replacing another single atom. So it's called a single replacement. It's like cutting in the dance, saying, here, get out of the way, we're together now, you go off and do your thing. Okay? So this is single replacement. Okay, got it? All right. Now in terms of balancing the combustion reaction, you know that combustion reactions have O2. And as said earlier, when you have hydrogen and oxygen together, the products are always going to be H2O. So that's it. There's nothing else. Now all we have to do is balance it everything. 2 hydrogens here, 2 hydrogens here, looking good. 2 oxygens here, 1 here. The only way we can balance this is by changing the number of H2O molecules. So we'll put the 2 in front, the coefficient. So now that oxygens are balanced, but now we have to balance the hydrogens. 2 times 2 is 4 hydrogens, so we need 2 hydrogens here, so that's balanced. Okay. This one can be tricky. We know we're going to add oxygen, and let's figure out our products. This is the challenge. Well, we have carbon, so we know we're going to end up with CO2. We'll leave a blank for the coefficient. We know we have hydrogen, so that makes H2O. And the last one here, we have sulfur. Sulfur and oxygen makes SO2, sulfur dioxide. Okay. All right, now that you have that, most of the battle is won. Let's see what we got here. Let's balance the carbons first. We save the oxygens for last, because they can be tricky. We got 2 carbons here, so we'll have to put a number 2 here to balance out the 2 carbons. Very nice. Let's take a look at, let's do sulfurs next. We got 1 sulfur here. 1 sulfur. You can leave it blank or put in 1. Let's put in 1 just for fun. And hydrogens, we have 3 hydrogens plus 1. That's 4 hydrogens. So this is 2 hydrogens here, so we have to put a 2 right there. Okay, see it? All right, now let's count our oxygens here. So we've got 2 times 2 oxygens, that's 4. Here we've got 2 oxygens, 2 H2Os. And then 1 SO2, so that's 2 oxygens there. So a total of 4, 5, 6, 7, 8. Over here, we have 1. And over here, we have 2. That's a total of 3. That's an odd number. The only way to get 8 oxygens, we would need, what is that? 3, well, we have to use a half number of oxygens. That doesn't work. So anytime you have an odd number of oxygens, the only way to remedy it is to multiply everything by 2. So let's multiply this by 2. We'll save the oxygens for last. We'll change this to 4. Change this to 4. Change this to 2. And now, let's see what we got. Double check everything. 2 carbons, 4 carbons, 4 carbons. Nice. 2 sulfur, 2 sulfur. Beautiful. 4 hydrogens times 2 is 8 hydrogens. 4 times 2 is 8 hydrogens. Very nice. Let's do the oxygens. 2 times 2, that's 4 oxygens. Over here, 4 times just there's 1 of those, so that's 4 here. And then 4 times 2 of those is 8. A total of 8, and 8 is 16. Over here, we have 2 oxygens, so that's 2. And we need some number to equal total 16. So this number has to be total how many? 14. So how many O2s do we need to get 14 oxygen atoms? 7. So there it is. So 7 times 2 is 14, plus 2. This is all balanced. Okay. See how saving the oxygens for last kind of removes a headache and saves it for later. Now let's do the next one. CH3 plus H8, adding oxygen. Okay. What is the product of carbon and oxygen? CO2. How about hydrogen and oxygen? You got it. H2O. All right, here we go. I kind of feel like Dora the Explorer when she goes like, and what's the capital of Zimbabwe? Good job. All right, anyway, here we go. Let's do it. So how many carbons? We have 3 here. Start with carbons first. We got 3 here. Good. How many hydrogens? We have 8 hydrogens. So how many H2Os do we need? That's right, 4. Okay. Now let's count the oxygens. 3 times 2 is 6. 4 times 1 of those is 4. That's a total of 10. Over here, there is none, so we can actually just fill this in. How many O2s do we need to hit a total of 10? Well, that would be 5. Got it? All right, that's it. First page.